Good morning, ladies and gentlemen, friends and neighbors, boys and girls. Today we're going to talk about Unit 10, Lesson 1. And before I get started, we would like to say hi to all of you out there since we haven't seen you very much. What's up? Let's talk about trig identities. All right then. Okay, so occasionally we will have a brief introduction by our friend Tigger. And the first thing I would say, this can be, I'm going to present this lesson in two parts. This is going to be part 1. We're going to continue this lesson with another video. This is can be kind of a tricky lesson. So it's nice that you have a video. You might have to watch the video a couple times to wrap your head around the content, what we're talking about. The first thing we need to understand is what is an identity. Because what we're going to do is we're going to talk about trigonometric identities. So the first thing we need to do is just realize what a mathematical identity is. So here I have this f of x is equal to g of x. This is an identity if this equation is true for every x value where either function is defined. So if f is defined and g is defined for some x value and this is true, then we can call that an identity. And we've talked about identities, golly gee, since pre-algebra for a long time. We just never did call them identities. And this is an important topic next year in calculus, identities. All right, so some of these identities should look very familiar. These, the ones that I'm going to circle in yellow, these are called the quotient identities. And these we have already discussed, and we've looked at all of those, and we've looked at how you evaluate those given the x and y values on the unit circle. But these are an identity. The tangent of A is equal to the sine of A over cosine A. This we know. The cosecant of A is 1 over sine of A. The cotangent of A is cosine over sine, and the secant is 1 over cosine. These are things you know. You know this, and this is a good deal. This particular identity here, we investigated this last week. And some examples of that identity are fairly straightforward. If I have the cosine of negative 2/3 pi, and you can check this with your calculator, if you will, that's the same as the cosine of 2/3 pi. So that's a fairly easy identity. Cosine of negative A is the cosine of A. That's going to always work. This is an identity over here. We haven't talked about this much, but this could be easily verified with the unit circle. If I come over here to my next page, I'm going to verify this particular identity. It's pretty easy to verify. The sine of negative A is equal to the negative sine of A. And let's see if we can verify that, or yeah, it's just a verification, not really a proof. I wish that line was straight, but it's not. I'm going to just do a unit circle here real quick. Pull that over here. Center it up there. Okay. So if I want to go, let's go a negative angle here. Let's just try the sine of negative pi over 3. Well, let's go to that. Let's change my, let's do a green line. Negative pi over 3 is going to be right there. Then this is pretty easy. This is negative pi over 3. And we know what this value is right there. That value is going to be negative square root of 3 over 2. And by this identity, this is supposed to equal negative sine of pi over 3. So if I go to sine of pi over 3, I'll come over here to my line tool, change my color. If I go to pi over 3, bam, where this angle here is pi over 3, and this value right here we know is square root of 3 over 2, that y value, and that is indeed, this is going to be negative square root of 3 over 2. So we have kind of verified that identity. We haven't proved it, but we verified it. We could actually prove that, but we're not going to worry about that. So the way we're going to assess this, Mr. O'Brien and I, we're going to have a Google document. You're going to have a couple videos. You're going to have an IXL. The IXL mostly are going to be concerned with this. But then we're going to have a Google document that deals with this identity, and then a couple of the other identities that we're going to talk about down the road here. Okay, so let's talk about this Pythagorean identity here. This is very, very, very prevalent in our study of trigonometry. There's a couple ways you can get to this. The reason why they call this the Pythagorean identity, and this is certainly worth a discussion. So I'm going to insert a blank page here and have a little discussion over this identity right here, which is called the Pythagorean identity. And there's a couple ways that you can get to this particular result. Pretty easy. Well, the easiest way, let's see if I can't do a straight line this time. Certainly the easiest way, if I have a unit circle, I'm going to grab a hold of that guy, center him up there, there we go. Well, this algebraically, and we've said this multiple times, this circle is given by this equation. X squared plus y squared is equal to 1. That's the equation of that circle. We could verify that too. This point here is 1, 0. This point here is 0, 1. And I'm just doing the nice points here. This is -1, 0. And if you notice this 0, -1, any of these points work in that equation. This is the analytical form of the unit circle. X squared plus y squared is equal to 1. This is the algebraic form, the algebraic form of the equation of the unit circle. And we would know that from our Algebra 2 classes, the equation of a circle centered at 0. And any of the points, and you could verify that, any of the points on the unit circle, if I want to, let's just go this point right here at pi over 6. If I let that angle be pi over 6, what's this point right here? Is the square root of 3 over 2, 1/2. And these values do indeed satisfy this equation where the square root of 3 over 2 squared plus 1/2 squared is indeed equal to 1. And I will let you do that verification on yourself. You can do the mathematics. Well, if I want to get to this, look how easy it is. Well, what do we know? By definition, by the trigonometric definition of the sine and cosine, if I'm on the unit circle, any point on the unit circle, let's do this in blue, any point on the unit circle is defined by the cosine of that angle, comma, the sine of that angle. And let's go ahead and sketch that angle. Let's sketch that angle in blue. And this is that angle. This is that angle right there, A. And we know that. This is our trigonometric definition of the trigonometry definition of the trig ratios. This x value is cosine A. This y value is sine of A. We know that. We've been doing that golly gee for weeks. So if I know this is true, and I know this is true, wouldn't it follow then that the cosine squared of A plus the sine squared of A is equal to 1? Indeed it would. The other way that you can verify this identity is if you look at, if we go back to the very beginning of our study of trigonometry, and we just look at this guy right here, and you're going to now find out why they call it the Pythagorean identity. If I have a right triangle here, and this angle is A, and this hypotenuse is 1, what do I know? Well, I know that the cosine of A is equal to this side right here. Call it whatever you want to call it. Let's call it K, is equal to K over 1 by the geometric definitions of the trigonometric ratio. The cosine is the adjacent side divided by the hypotenuse. And what is the sine of A? The sine of A, call this whatever you want to call it. Right now, let's just call it J, this side opposite of A. So the sine of A is going to be J over 1. Well, therefore, K is cosine of A, J is sine of A. What do you know by the Pythagorean theorem that you know K squared plus J squared is equal to 1? Why? Because 1 squared, which is 1, because of the Pythagorean theorem. The Pythagorean theorem. Hey, what is K? Cosine of A. So this is the cosine of A. Plus, what's J? Sine of A. And this is that identity we talked about. And this is the reason why they call it the Pythagorean identity, is because you're going to use the Pythagorean theorem to develop that, because you can use the Pythagorean theorem. So there's a couple ways that we can get to this formula, this identity, sine squared of A plus cosine squared of A is equal to 1. Lots of ways you can get to that. I did it first with the analytical definition of the unit circle, the algebraic definition, x squared plus y squared is 1, and knowing that any angle, the x value of that angle is cosine A, the y value is the sine of A. And then I came down here, and at the very beginning of my discussion of trigonometry, I used geometric definitions. I have a right triangle here. The cosine is opposite over the hypotenuse. The cosine is adjacent over the hypotenuse. Sine is opposite over hypotenuse. And then I'm going to use the Pythagorean theorem to get that. What is K? What is J? So this is a very prevalent identity. Let's go back to this page. And this you could put in a blank page in your interactive notebook. So this is one of the most important identities right here, the Pythagorean identity. And we're going to use that down the road as well. Well, and here's another form of the Pythagorean identity. This is an equation identity that's true. Well, look, if I want to just solve for cosine of A, what do? I just subtract sine squared of A both sides. So cosine squared, and we're going to see this often, is equal to 1 minus sine squared. We're going to use that identity. This is also a form of the Pythagorean identity. In like manner, what if I want to just solve for the sine of A? I just subtract cosine squared. Cosine squared of A. So this is another form of the Pythagorean identity, where sine squared of A is equal to 1 minus cosine squared of A. Okay, so we're going to use these three Pythagorean identities a lot. This guy right here, and this guy. So these two guys flow from the original Pythagorean identity. This guy was a new identity, or this guy we did last week, and this rascal here was a new identity. And these we should know, heavens to Betsy. We should know these. Alrighty, so we have a few minutes left of this video, and now we're going to, look at what we're going to do here. And this is not going to be very fun for a lot of people, but still necessary. Look at what we're going to do. We're going to use these identities, to prove other identities. And I will tell you, this is very uncomfortable for a lot of students. This is going to be very uncomfortable for a lot of students, and a lot of students are going to have this look. Oh no! Or they're going to have this look. I'm angry. This can be a difficult topic, how to prove trigonometric identities. And here are some nice hints. The first thing I'm going to do is write everything in sine and cosine. We're going to start left side and end and use some algebra to end up at the right side. We cannot forget where we want to go. Don't forget where you want to end up. And here's key. You cannot start with what you want to prove. And we're going to have some very creative ways to assess your knowledge of proving trigonometric identities with the Google form. So what we're going to do a couple easy examples in today's video. And then we'll have some tough examples in tomorrow's video. So here is example number 1. What I want to prove is I want to prove that secant of A times the sine of A is tangent of A. So you have to be very careful here. We want to end up with equals tangent A. We cannot start with that. We can't start with this equation, so all we can do is start with the left side here. The secant of A times the sine of A. Well, and then we're going to just walk down. Hey, what's the secant of A? The secant of A is 1 over cosine of A. I knew that from the quotient identity above, right here. The secant of A is 1 over cosine times the sine of A. Oh, over 1, of course, because there is no denominator here, so the sine of A is 1. Hey, what's 1 over cosine times sine over 1? That's going to be the sine of A over the cosine of A. Hey, which does indeed equal the tangent of A. And we have proved what we wanted to. And I will tell you, ladies and gentlemen, this one was easy. And a lot of you right now are thinking, oh yeah, I got this. Give me some other ones. I'm really happy about this one. Oh yeah, even got my dorky glasses on there. So let's do another one. I think we have time for one more in this video. All righty, example 2 here, where I want to prove that, this one looks difficult. Don't be intimidated by it. So I'm going to rewrite this. What do I know? I know in parentheses, secant of A plus the tangent of A, close parentheses, times the secant of A, minus tangent of A. I want to prove that that's 1. So at the very end of this, I'm going to go equal 1. Don't put an equal 1 on it now. This is the right side. So we're going to start with the right side and end up with the left side down here. And if I go back to my hints, what's the number 1 hint that I had? Write everything using sine and cosine. All right. Let's do it. Let's write everything in sine and cosine. Well, what do we know? We know that secant is 1 over cosine. I'm going to try to get my handwriting a little bit better. What's the tangent? The tangent is the sine of A over the cosine of A, in parentheses, times secant of A, which is 1 over cosine of A, minus tangent of A over cosine of A. Now, and I would like to, excuse me, tell you, first off, a little geography lesson. There are more ways than one to get to Versailles from Madison. You can go straight up 421. You can go to North Vernon and east on US 50. You can go down to Vevey and then up 129. More than one way to get to Versailles. Excuse me. So I'm just going to throw that out there. And I'm going to demonstrate one way. All right, so what's the first thing I'm going to do here? Hey, I have addition of fractions and addition of fraction, which is pretty nice because both of these fractions have the same denominator. So I'm going to add these fractions here. And this is going to be 1 plus the sine of A over cosine of A. Times, and I'm going to do the likewise here. They both have the same denominator. So I'm going to add those fractions. Keep in mind, I'm going to end up multiplying these things together. If I add these two fractions, I add the denominators, pardon me, add the numerators, and leave the denominator go. Okay? Now I'm ready to do some multiplication. And just for a brief moment, I'm going to cross that off because I'm going to continue down here with my identity proof. And now, if I multiply the top, look at what the top looks like. The top is 1 plus the sine of A times 1 minus the sine of A. The bottom is simply going to be cosine squared, because it's going to be cosine times cosine. All right? So if I continue down here, hey, what is 1 plus, excuse me, what's 1 plus sine of A times 1 minus sine of A? That rascal, ladies and gentlemen, by the difference of squares property, is going to be 1 squared minus the sine squared of A. Keep in mind, I'm still over cosine squared of A. Oh, what is 1? 1 squared is 1. What's 1 minus sine squared? 1 minus sine squared, ladies and gentlemen, is cosine squared of A. Over cosine squared of A. Hey, what's cosine squared of A divided by cosine squared? What? Heck yeah. Proof finished. Okay, so we're about 23 minutes on this video. You might have to re-watch this. A lot of stuff at the beginning of this video maybe was a review, and that's okay. This, I understand, is a tough problem. What we're going to do with our Google assignment is we're going to give you an identity to prove and just show you a couple steps, and you're going to determine whether that step is true or false. So we'll be very creative on the Google assignment. Some of them will be very easy. All right, so I'm going to sign out. I will talk to you soon.